Okay, this is problem number 8 on chapter 8, section 1. In this problem, they give you the test statistic. It's given here. That is the test statistic, 1.86, and is obtained when testing the claim that the population proportion is greater than 0.7. The first part says identify the hypothesis test as being two-tail, left tail, or right tail. As you can see here, this mathematical symbol of a greater than corresponds to the alternative hypothesis. Remember, the alternative hypothesis only gets mathematical statements as greater than, less than, or different. Since it is a strictly greater than 0.7 symbol, we use a right tail. Okay, this part tells you right here. The symbol greater than points to the right, and the test is a right tail. So that's how you fill out this this part of the problem. Here, the second part. On the second part, they ask for the p-value. So first of all, let me state the null hypothesis and the alternative hypothesis. The null hypothesis only takes equality, and the alternative hypothesis, it takes either one of these symbols, in this case greater than 0.7, and that is the claim as well. Okay, so I will write P is greater than 0.7, and the alternative hypothesis only takes the mathematical symbol of equality. So that's the only one. It goes here on the null hypothesis, and the claim is here. That is important to specify what the claim is. Sometimes it's on the alternative hypothesis, sometimes it's on the null hypothesis. In this particular example, it's on the alternative hypothesis. The test statistic is a 1.86. So 1.86, let me mark the mean, which is 0. Since the test statistic is a z-value, 1.86 again, yeah. It will be located maybe this far away, here. Z equals 1.86. Okay, 86 here. And by definition, the p-value is the probability of getting a value of the test statistic that is at least as extreme as the test statistic obtained from the sample data. So you are looking for this probability, z greater than or equal than 1.86. So we are looking for this this right tail. Remember, I mentioned from part A, this is a right tail. They want this area, the probability of obtaining a value, a test statistic of 1.86 or greater than that value. For this, I use the calculator. Let me reset the calculator. Second, 7, no, plus 7, 1, and 2. I just reset my calculator, and I'll use normal CDF. Since I want area, I use normal CDF. We go to second vars, number 2. My lower limit is 1.86. 1.86. My upper limit, I will choose any extreme positive value. In this case, it will be 10,000. I will use 10,000. I keep the mean and the standard deviation as 0 and 1, and I paste that information in the main screen. and that's what I get for the p-value, 0.031, rounding these to 3 decimal places. Okay, so the next part, we gotta decide if we reject or fail to reject the null hypothesis. Remember that this is the assumed value. So we have to decide if we reject that assumed value or we fail to reject. So this is the part that tells you how to make that decision. It says if the p-value is less or equal than alpha, where alpha is the significance level given in the problem right here. The significance level here is 0.01, right here. For this particular case, the significance level is 0.01, and the p-value you obtain in this part is 0.031. So if the p-value is less than the significance level, we reject the null hypothesis. On the other hand, if the p-value is greater than the significance level, we fail to reject the null hypothesis. In this